I see we have to.
Hello, everyone. Welcome to the University's Research Association URA National Lab Seminar Series. We are delighted to have you with us today. Headquartered here in Washington, D.C., URA is a nonprofit consortium of over 90 leading research universities across the U.S., the U.K., and Italy. Our mission is to accelerate scientific discovery by strengthening the exchange of expertise between academia and our national laboratories. In this capacity, URA serves as the parent organization managing Fermilab and provides key support to Sandia National Laboratories. The goal of the National Lab Seminar Series is to broaden your understanding of the range of career paths available with a STEM degree beyond traditional academia and to learn more about the work being done across the 17 U.S. Department of Energy national laboratories. Throughout this presentation, please use the Q&A feature at the bottom of your screen to ask questions for the Q&A session, which will be held at the end of this presentation. And so we're pleased to welcome our speaker today, Dr. Giselle Sandi. Dr. Giselle Sandi is the Director of Research Excellence Programs at Idaho National Laboratory, where she manages professional development, funding and award application support, the publishing process, and student, faculty, and postdoctoral programs. Dr. Sandi has 25 years of experience within the national laboratory system and 35 years of experience in academia. Her technical background is in energy storage, nuclear forensics, nanoscale engineering, and in situ characterization techniques. Prior to joining INL, Dr. Sandi was the Deputy Division Director and Division Operations Lead of the Chemical Sciences and Engineering Division at Argonne National Laboratory. Dr. Sandi holds a PhD in chemistry from Northern Illinois University and a Bachelor's of Science in Chemistry from the Universidad de Costa Rica. Welcome, Dr. Sandi. The floor is yours.
Thank you so much for your kind introduction, and I want to thank all of you for being here with us today. I hope where you are is sunny. Where I am, it is. So I hope you all are enjoying your day and a very productive day as well. So I am going to actually explain a little bit about my professional journey. I will also discuss about what my research was, very, very generic aspects of my research, what we are doing now at Idaho National Laboratory, and what opportunities, professional opportunities are there for undergrads, postdocs, early career, and anyone who would like to join this wonderful laboratory. So first of all, let's see if we can move that. I was born in a Latin American country, and it will be curious to see you guys can put in the chat where you think I am from. I'm gonna give you about 10 seconds to do that before I move to the next slide. Not even that, you just guess where I'm from. I don't see, well, unfortunately, I cannot see actually the chat, but I'm gonna move, and I hope the winner are those who say that I was born in Costa Rica. So if you have not been in Costa Rica, it's a beautiful country in Central America. So I was born in the capital, San Jose, and a small town called San Antonio de Escazú, up in the mountains. So it's about the town where I was born. It's about 4,000 feet elevation and is absolutely gorgeous. So if you ever want to go to Costa Rica, the best time of the year to go, and it is a PR for the country, is between December and April. This is what we call our summer, which really means our dry season. It's really gorgeous, but throughout the year, you will love it. I was born there. All my family is there. I was the only one who moved to the United States to pursue my academic degrees. So again, hola a todos and bienvenidos a mi seminario. So I'm going to talk a little bit about my professional path. And this straight arrow is obviously never straight, right? So this is simply an easy way to represent someone's trajectory. But as many of you know, um, anyone's path will be with ups and downs and curves and dips and so forth. So just for easier representation, I'm going to tell you a little bit about what I have done in the past few years with my career. So I did, as mentioned in my introduction, kindly, I did get my bachelor's degree and another degree called licenciatura, which is very similar to a master's degree, both from the University of Costa Rica, Universidad de Costa Rica, in chemistry. So chemistry has been my passion ever since I was actually in high school. I had a amazing teacher, professor in high school who really instilled in me the passion and the love for sciences, but specifically in chemistry. So I was able to receive full blown scholarships to the University of Costa Rica, which is the largest of the country and the rank number one in the country. I did also at the same time when once I graduated from the with my leg, which is again equivalent to a master's. I became an instructor at the University of Costa Rica in analytical chemistry. I really love, and I still do, interacting with students. I believe that passing my knowledge to them, my experiences, is a way to amplify the love for sciences and making everyone, love sciences and be impactful in the field. When I was finishing my master's degree, we had a professor from the University of Wisconsin who was a Fulbright scholar at the University of Costa Rica. He passed away, unfortunately, not many years ago. His name was Lyle Hall. And Dr. Hall, Professor Hall, was teaching us physical chemistry. It was actually the lab and the lectures in physical chemistry. And he recognized that a lot of us, many students at the University of Costa Rica, were talented, and we could actually come to the United States and to Europe to do PhDs to pursue graduate school in other countries. So he helped us literally to complete applications to different universities in the United States and some in Europe as well. So I ended up, don't know why, I didn't know the weather very well, but at the time, I was actually given a full scholarship to come to NIU in DeKalb, Illinois. And that is around about 60 miles west of the city of Chicago. I remember coming, getting to the airport, getting into O'Hare Airport, huge airport, and my advisor at the time, the person who was going to be my mentor, kindly picked me up, as well as a couple of my colleagues from the university who also came with me. And we drove. We drove around, so kid, going to the suburbs, so good. And then all of a sudden, corn in the fields of Illinois, which was a little depressing at the beginning, but in the end, it was actually a really good experience. So I ended up finishing my PhD in 3.5 years because I had quite a bit of experience in research before I came. And I was actually very lucky to, before I finished my PhD, I was connected. And this is when it's so important that to connect with professionals, with anyone who can open doors. I connected to with some professors at NIU who had appointments at Argonne National Laboratory as joint appointments. So some of them recommended me to talk to scientists at Argonne. And before I actually finished my PhD, I had already aligned a postdoctoral fellowship at Argonne National Laboratory, an immense experience that I never forget. I was actually able to, do my science, work with brilliant minds in the laboratory, and grow. Right, make mistakes like all of us do, but really grow academically and professionally. So I moved through the ranks from being a postdoc to a scientist. And then I started to like a lot of the what we I call research administration. So I was asked if I wanted to lead the postdoc programs at the lab, and I took the chance. It was a risk. And I said, yeah, I can help, but I really didn't know what it meant at the time. So sometimes you also have to say yes to opportunities, even though you don't know exactly what it means, but if you work hard and if you have an open mind, things will go well. And so I did take that opportunity. And I then actually transitioned full time to become the postdoctoral lead of the laboratory. And at that time, there was a survey called The Scientist, and Argonne was actually the postdoctoral programs at Argonne was placed at number 4 in the country under my direction. So I was very pleased to have that. However, I continue to love science, and I have been very lucky to have been associated with institutions where science and research are core of that. So my successes as a program lead or postdoctoral lead at Argonne make other people recognize me in the Chicago area, and I was actually asked to lead the research mentoring programs at Rush University Medical Center in Chicago. And also at the same time, I was given the opportunity to be a faculty and associate professor in the medical college, specifically working with the orthopedics team, working on corrosion based on my experience in electrochemistry. Again, an immense privilege to work with the researchers at Rush, an immense privilege to actually lead the mentoring programs at the university with more than 2,000 people that actually I was able to work with. Lots of leadership experience I learned with Rush, colleagues that up to now continue to be in my network, and a lot of MDs and doctors and MDs and PhDs who actually literally became my own physicians. So I still continue to have ties with the university in that capacity. One thing I neglected to say is that as I was working at Argonne as a scientist and postdoc lead, I was also an adjunct faculty at the Illinois Institute of Technology, where I had the privilege to actually advise 12 PhD students and 6 master's students. So again, an incredible privilege to work with them, and a way for me to also expand my research and to continue mentoring the next generation of researchers in the country. Um, I was called back to Argonne in a way, or in other words, people encouraged me to apply to the Deputy Division Director position of the Chemical Science and Engineering Division at Argonne, which was an honor to have that role for 3 years. And then in 2023, beginning of 2023, I was very honored to be appointed the Director of Research Excellence Programs at Idaho National Laboratory. Also, I have to say that throughout my career, pretty much, even as a postdoc fellow, I was a adjunct faculty at Benedictine University teaching chemistry. So you can see that I have a passion for science, a passion for teaching, and also, of course, a passion for helping the next generation of researchers so that they actually can be very successful and move forward. So that's my path, and I already took quite a bit of time on that. So if you have questions along the way, excuse me, at the end, please ask me about that. But again, that wasn't a straight line. It just happened that everything that I did up to being the division director, all the experiences here, or deputy division director, excuse me, helped me to position myself for the role that I have today. I'm going to only show you 3 slides about my own research. So my focus as an electrochemistry was in research in the synthesis and fundamental studies of transport of lithium-ion batteries. But my focus was on carbon, on the negative part of the battery. All of you have cell phones, all of you have iPads. Every single device that has a rechargeable lithium-ion battery actually has the carbonaceous piece And if you're driving a electric vehicle or a hybrid car, you will have the metal instead of the anode, the carbon. So I did a lot of years of research understanding the transport at the fundamental study with the idea to then transfer that knowledge into more applications. And so that was a fascinating field. I used so many techniques at the advanced photon source, the Brookhaven immersional light source, so many areas of research that actually were, or many collaborations as well with not just chemists, but also chemical engineers, computational scientists to model transport, etc. So if you are a battery expert, you know that this is the typical diagram that we show to understand the transport. But I really spend most of my time synthesizing the carbon anodes and understanding how we can actually make them more efficient. And just as an aside note, the three pioneers who got the Nobel Prize in chemistry due to the lithium-ion batteries were John Goodman, who unfortunately passed away a few years back, uh, Stanley Whittingham and Akira Yoshino. I did not have the opportunity to work directly with them, but I was in the Electrochemical Society meetings and the ACS meeting, American Chemical Society meeting, many, many, many times with them. Amazing, brilliant scientists and human beings to the core. So I was when they received the Nobel Prize, it was just an honor to get to know them, and it was an amazing opportunity. You want to read more about that? There's an article here that was published a little bit back in 2018, where they actually this is a summary of how was the discovery of the lithium-ion batteries and why they deserve the Nobel Prize. Other areas that I was a collaborator, not necessarily a principal investigator on that, was cathodes. As I mentioned in the schematic before, you need obviously the electrolyte in the metal. You need the cathode and the anode for the transport to happen. So colleagues at Argonne National Laboratory at the time actually were the pioneers in the cathode area. So my contribution here were more in the characterization, more on spending time at the beam lines and understanding how the cathodes actually perform in real time, in situ characterization techniques, etc. So I was able to contribute a little bit to the research, but as a collaborator, not as a principal investigator. Another interesting work that I did was in understanding or working with graphene sensors, mainly for optimization of recovery of strontium from actually urine in soldiers. We wanted to understand, for example, if soldiers were in a field where there was radioactive materials, and we wanted to have small sensors attached to either attached to them like that, or actually collecting samples afterwards to see if they were contaminated. So extraordinary science that actually was conducted at Argonne at the time. So I wanted to say that no principal investigator, no professor actually can do the science without students. And here I am with my first ever community college student, David Bordenau, at the time from University of Texas. And look at my hairdo. So there was that time. This is probably 1994, so at the beginning of my postdoc years. And then I have the opportunity to mentor many, many grads and undergrads. As I said, lots of undergrads in the summer. And Risa Kizilel, the tallest guy here, was actually one of my best graduate students I had. And he's now in Turkey. He's the director of an energy center, an amazing student at the time, and obviously a very successful scientist. So again, it was my favorite part of the year when I actually had the opportunity to be with the undergrads, but throughout the year, actually working with the grads was actually an honor as well. So let's focus now on looking at the clock here. Focus on who we are at Idaho National Laboratory and why is one of the best places I have ever worked. There's a lot of one first. So the heritage of the laboratory was the National Reactor Testing Station drove nuclear innovation in the US and around the world. So the first nuclear plant was actually developed there, the first US city to be powered by a nuclear energy. It's a small city in Idaho. I have been there, a really, really nice historic site. Submarines reactor were tested, excuse me. Around the mid 90s, there were about 40,000 reactors operator trained in the site and mobile nuclear power plants for the Army as well. And it continues. Still, there's a lot of research that actually is in tangent with, looking at how to power submarines and so forth. In addition, of course, to the nuclear power plants. So, super interesting place to be. So we cannot really do anything without having a vision and a mission. So we are enabling energy dominance and security through research, development, and demonstration. And our vision is to change the world's energy future and secure our nation's critical infrastructure. And our mission is to really discover, demonstrate, and secure innovative nuclear energy solutions, other clean energy options, and critical infrastructure. So this is the core of what Idaho National Laboratory is. And if you come to work with us, you will feel that way everywhere you go. And so it's an honor to be working with so many people who every day really bring in innovation, passion, and moving research and technology forward to accomplish the vision and the mission. And they said a video or a picture is worth more than 1,000 words. So I'm gonna play a video that only lasts 1 minute, but I think it will you will appreciate what I'm saying here.
Our research at Idaho National Laboratory is creating a better future for us and our children through groundbreaking scientific advancements. Imagine a world where your home is powered by abundant, affordable, and reliable power delivered through integrated energy solutions, where our critical infrastructure is safeguarded through cutting-edge cybersecurity, ensuring the lights stay on and clean water keeps flowing. We're discovering solutions to global energy problems and pushing the limits of innovation, harnessing the power of nuclear energy to power deep space exploration with advanced systems assembled and tested right here at Idaho National Laboratory. We're developing the next generation of compact, advanced nuclear reactors, delivering 24/7 energy, designed to power our grid, even in the most remote locations. And we're improving recycling techniques for used cell phones, laptops, and other e-waste to recover the critical materials needed to manufacture everyday products. We're not just imagining a better future, we're building it. For us, for our children, for everyone.
I hope you are as excited as I am when I see this video. Let me see if we can move it forward. Okay, so obviously we are a lab, as we are one of the 17 labs from the Department of Energy. And here are little numbers. You know, you don't have to really dig in on those numbers, but half of our funding or so forth comes from the Office of Nuclear Energy as well as the Office of Critical Minerals and Energy Innovation. We also have a very strong portfolio. About 1/3 of our funding comes from national security in many ways. And then we have the balance, about 17% comes from other Department of Energy laboratories, including the Office of Science, where we have a smaller budget here, but this is where we do fundamental sciences as well, and other strategic partnership projects as well. So in fiscal year 2025, we were a little over about 6,500 employees. And then that number fluctuates, and I think other national labs have the same. About 130 postdocs and 2,400 facility users, 17 joint appointments. At that time in 2025, we have 618 interns. Right now, we have about 530 or so graduate fellows and about 13 and 50 visiting scientists. So our budget is over $2 billion. And you can see the distribution here, but it is, I would call it a medium-sized laboratory in terms of budget, but the mission is very robust. So we have the combination of a lot of different programs where people work in different areas. So this is very important to us. This is the science and technology initiatives, what we call our core mission and strategic trust. So the core missions are nuclear, as you can see already with from the video and everything that I have shown you before, national security and critical materials. So those are what we call the core mission areas. And then the trusts are artificial intelligence. You all probably are already familiar with Genesis. Integrated energy overall, not just nuclear, but many other solar, fuel cells, batteries, etc. Fusion is an area that is very critical for the laboratory and growing very quickly in space and defense fission. So those are the other four thrusts that we have actually programs and moving forward and increasing those programs. Many of you probably heard all about one reactor on I think it was June 4th when it went critical at INL, and that was Antares. Antares Mark Zero. Antares was the first of the new reactors being developed that actually went critical, a huge step in understanding how then this criticality can lead to a full blown reactor, right? And I think you also heard recently that last week another reactor went critical, although not at the lab itself, but it was actually through collaboration with INL, with Idaho National Laboratory, and with scientists of Idaho National Laboratory that actually that happened. So very, very exciting time for us, a very aggressive timeline to building all these reactors that you can see from now until 2030. Our lab director always emphasizes that it has been probably more than 45 years or so that really a reactor has not been built, and now we are really in a moment in history with hopefully before July 4th there will be another reactor going critical. So that's actually very exciting news. And okay, so now we come to how you can be part of us. What areas, what I'm doing at the laboratory, what is my team doing at the laboratory, and what opportunities you have to join the lab. And if you have questions, again, we're happy to answer them at the end. Otherwise, just contact me and we're happy to continue conversations. So I manage what we call the Research Excellence programs at the laboratory. I report directly to the Deputy Laboratory Director for Science and Technology, and he's also the Chief Research Officer of the laboratory. And he indeed reports to the Lab Director. So research excellent programs, if we divide it, we don't, but if we divide it to make it easier for everyone understand. So we have within research programs, we manage external awards. We have data analytics to help us understand our scholarly output, also anything to do with our programs in terms of appointments, students, postdocs, numbers, institutions, or all of that. We actually have data for it. I am the sponsor of the Early Career Research Association, and we work with them again to help with professional development and to really have a presence of the lab in the laboratory. Part of my group also manage the human subjects research. We have launched a little over a year ago what we call the One INL mentoring program, where people from different organizations match based on interest. And it's not just for researchers, but it's for the whole laboratory. I do coordinate the Office of Science efforts for the laboratory. Again, we are not an Office of Science. However, we do have projects and funding and from the Office of Science. So I am the liaison to that. We obviously are very important in terms of research culture. So we have programs that are aimed specifically to address or to help with that. Research security, as you can imagine, in every lab right now, this is an area that is very important. And of course, centered to my heart here is professional development. It's very important that we provide the resources necessary for the success of everyone. In terms of qualifying as educational programs, but it's really part of research. The internships programs, we have the what we call the Battelle, because the lab is actually managed by Battelle. So we have internships that are paid by the programs that researchers have, as well as externally funded internships too. We have the SULI program, we have the CCI program, et cetera, from the OE, etc. So I'm gonna tell you more about in the next slide or so. We manage or we help to manage the postdoctoral office. We have a postdoctoral office to help with the postdoctoral programs. And part of what we do as well is manage the faculty appointments and academic and visitors. So congratulations to my team. They are outstanding people, and we do a lot of things within our preview. So what opportunities you can have at INL, at Idaho National Laboratory? We always are looking for incredible interns, right? So right now, as I said, we have about 540 interns, and we hope to continue growing that number. And they gained really hands-on experience in science, energy, and national security. And the applications are open year round. So if you actually go to inl.gov internships, you will see that you can apply, even if it's not the summer or spring or the fall, you can always apply. And we will, the talent acquisition partners in human resources will get your resume, etc., and then you will be contacted as if opportunities actually open up. So don't wait until the next summer to do that apply. We also have the opportunities for graduate students to do Office of Science graduate student research programs. And this is it's actually a fellowship that to help you advance your PhD thesis while working in a national laboratory. Please, graduate students, if you are listening to me, this is an outstanding opportunity to bring your ideas aligned with the Office of Science and bring it to us to work with world-class scientists that will help you. They will be your mentors, but your ideas will be actually accomplished working with us. So if you actually search Office of Science graduate student research programs, you will see on their website how to apply and the requirements, etc. Postdocs, we welcome postdocs. We hope to grow our number of postdocs at the laboratory. And there are, a few things that you have to be completed your PhD within 5 years, so some requirements. And the main thing is that we want to prepare you to transition to a research independence or position. We have a higher conversion of postdocs to staff. Excuse me, I think I went behind quickly here. And if you hear the link that you can actually go and browse that, feel free to please reach out to us. And this is a very new program. It's called Metallic Lift. It's a new program. It's a collaboration to increase workforce development in critical minerals and in materials. So if you are interested, please reach out to us. We already are trying to hire some students for the fall. But again, there's some specific requirements for this program. But we welcome all the questions that you might have and happy to have conversations with you. As I said, a little bit about the internship program. We have about half undergrads, and so 55% undergrads versus 45 grads, take and give. So more than 500, 530, 450 a summer. Again, is we have the SULI CCI, the Office of Science Graduate Programs, and also, of course, funded by departments. We have a series of core competencies that actually we use to offer as professional development opportunities. And we also require deliverables. So in other words, before you leave, if you are in the summer or fall or spring, you will have to show us what you did. And we have opportunities for you to do that. A poster session, you can do talks, you can do a prototype. So there's a lot of opportunities for you to actually show us the outcomes so you're staying with us. The core competencies are actually, again, we covered all the core competencies throughout the either the summer or any of the other semesters that we host or through the year, but it really are essential skills. Those are marked skills, behaviors, and knowledge area that are essential to you, and we actually then create a curriculum development aligned with those competences. So here is what things that we cover: professionalism, communication, teamwork, critical thinking, work ethics, technical proficiency, adaptability, initiative, AI, and learning mindset. So it's really a robust opportunity for all of you during the tenure that you are here with us. And then, of course, it is so important to have clear expectations from your mentors and the mentors to you as well. You want to make sure that you understand what you're going to be doing. And the mentor also tells, had an opportunity to have a conversation with you and align those expectations. So we actually have this memo of expectation for interns where we talk about the background of the project, work assignment, deliverables, and this is all done in a way that is hopefully easy to keep track of. So this is very, very important, especially for interns who have not been in the lab before or any other jobs. This is very important. And we talk about deliverables, lots of opportunities for you to show what we do, that you did, posters, lighting talks, presentation, prototypes, etc. So publications, we hope, etc. So those, and then we're gonna post the abstracts online as well. And we talk a little bit about the SULI program and the CCI. So those are 4-year undergrad. So for the SULI is 4-year undergraduates institutions and community colleges, and for the CCI community colleges, specifically designed for students who want to do research, who wanted to understand how it's looking, what it is to work in a national lab. This is sponsored by the Office of Science WTS program. And so you have to apply and choose us. And so then we match you with the best mentor for your interest. And be mindful of the application because the applications are very tight. They should not be late, etc. But we hope that you consider us as well. So you are paid by the DOE Office of Science. The postdoc program, one of my favorites, of course, I hope that we continue to grow the program. And I said before that we have a high conversion rate. Last year, we have a 65% conversion rate to full staff after 2 years of the program. We are part of the National Postdoc Association, like all the national labs are. And we do have a very strong postdoc association teaming up with us, and they do have a strong presence at the laboratory. We have poster sections, we have, dinners and awards. They created a Shark Tank competition that now is used for our LDRD program. We do a speed networking, so many things that are amazing that the board actually come out with ideas and they execute. So thank you for your partnership. And so here coming to the end, so we have time for questions. We really are building the workforce of the future. and we want you to come and work with us. We want you to come and explore what it is to work at Idaho National Laboratory. Here are some of the fields, and this is not by any means a exclusive, an inclusive list. There's a lot of more things that, fields that probably we did not include here. There cannot be, with so many of them. But advanced energy system, manufacturing, biological processing, of course, chemistry and chemical engineering, computational, cybersecurity, critical infrastructure, data science, electrochemistry, and the list continue go on and on. And but also we have a lot of opportunities that are more operation based, not just necessarily doing the research and executing the research, but also program management. We can also have wireless communication, software development, welding, union trades, many other areas where we need lots of talented and dedicated people with innovative ideas to come and join us. So I think this is my last slide before I wanted to actually leave you with this thought that I strongly live by. And as you know, you have to hear about Maya Angelou, was one amazing writer, and this is, I think you have heard this many times, but I learned that people will forget what you said, and people will forget what you did, but people will never forget how you make them feel. And what I want to say is that when you are working with your interns, with your mentor, etc., make sure that you have a strong communication, open ways, and that you really are honest about what you do, and that everything you do, you know that you have an impact. The work that you do is impactful, no matter what field you are. And with that, I think I end the talk, and I'm going to close the slide so I can see you, because right now I won't see you. I cannot see you, but I want to see some faces. So I'm going to close my slide. And if I don't think I need my slide to answer questions, but I will do that.
Thank you so
Okay.
much, Dr. Sandi, for that presentation. That was very informative, and I appreciate you giving a timeline of your career path and also the work that's being done at INL. So just to remind all attendees to please use the Q&A feature at the bottom of your screen to go ahead and type out your questions, and we will get those asked. To kick us off, you mentioned INL has some nuclear reactors that have gone critical or planning to go critical. Could you talk a little bit about what that office culture might look like when a nuclear reactor goes critical? To me, I'm envisioning celebration, like when we land
Yeah.
people on the moon. So could you
Mhm.
talk a little bit more about what that looks like when we do
Yeah.
have a nuclear reactor that goes critical?
So I wasn't at the site at the time, but I saw a lot of postings, a lot of, our director it is so excited about talking about this, because this is a historical moment in the country right now, in the United States. So is in a way, is like really accomplishing something that it didn't, hasn't happened for more than 4 decades. And then with all the work that so many people are putting, all the contractor work, all the scientists at the laboratory, all the researchers, all the technicians, everyone working overtime, working weekends, etc., sustain a reaction, right? We're not giving energy yet, right? But sustaining a reaction, able to actually have that chemistry and that simulations, really, okay, everything that we anticipated is happening. Is it probably was when if I were there, I could hear the energy in the moment, right, in the room, screaming, etc., and immediately all the posting went wild everywhere in the world. I think it did. So an amazing, it's just, I suppose it's the same feeling as someone is told you won the Nobel Prize, right? Is, in my opinion, very similar feeling on that.
Thanks for that. A question from the audience. Were there moments when balancing family and career felt particularly challenging, and how did you handle them?
This is a question I get all the time, and I think I asked so many people the same question when I was, going through being an early career and moving forward. I do have three boys, well, now are men, It was very difficult when they were young kids, balancing the load of, being a mom and being a scientist, securing funding, writing proposals, being a good member of my community, doing outreach because I really believe in that. Um, but I think one secret, I guess, is to have a good partner. And I have a husband who has been an incredible partner throughout my career. He's also professional. He has a PhD in computer science. And so at times he gave up a few things. At times I gave up opportunities. And we always have a core value, and the core value has been family first. No matter what, for us, family has always been first. So I have passed amazing opportunities because we could not move. We have some constraints in our family that allows us to move, too much. But it has been always the main thing that we always have is family first, and we always be together. Now, for some people, is other values, right? So I don't think it's just one recipe, but I would say that how I did it when my kids were young is tons of help, right? Don't do it alone. Find babysitters, find neighbors, bring your mom. You need to bring them. Uncles, try to create a large network so that you are not doing the work alone. You cannot do it alone. Um, and some people say you never really achieve balance. You achieve what you can, and I believe so. I don't think it is 50-50 never. It's going to be always that compromise. So.
Thank you for that. Another question from the audience. Did you go straight from a bachelor's to a PhD? And how long does it take for a nuclear reactor to go critical?
Oh, okay. So the second question, I'm not an expert on that, right? So I will actually would say that I might be able to find the answer and send it to the person. If they leave me my email, I will do that because I'm not a nuclear engineer. Um, I did actually go, I went from my bachelor's to a similar, which is a master's degree, similar to it, and then PhD. Now, I actually recommend everyone to go directly for the PhD if they want to do that, because sometimes is once you see money and you go to work, it is a little hard to then come back to do a PhD. If you already have that in mind, search programs, see what areas you are interested, read papers of professors who have published in the area that you are interested. Ask mentors, do a lot of research. Now, uh, a PhD is not an easy thing to do, right? So when you decided to go for a PhD, make sure that this is in your heart, that you really, really love science, that this is your passion. It is hard to do it. But if you really love research, this is the most wonderful thing you do. But you really have to have that in your heart.
And going off of that, in terms of a PhD, another audience member asks, why do a PhD in chemistry versus physics/math? Did you like working with chemical reaction/ chemistry of things in comparison to working in more of a theoretical field like these?
I personally was a hands-on person, right? So I'm more of a let's go to the lab, let's conceptualize an idea, let's design an experiment, let's do it. But they are obviously theoretical chemists, computational scientists, theoretical physicists, right? We do need all of you, right? There is not just a single. I probably was not smart enough to be a theoretical chemist, right? You really need a lot of math tools to be able to handle that. But I love going to the lab. I love experimenting. I love having my hypotheses. Either they were right or they were wrong, but experiments were easy for me to actually be able to see that. But of course, I had a lot of collaborators through my careers who were theoretical chemists. And so between my experiments and their models, we were able to then speed up, right? I would say the outcomes of my research. So all of you are needed. If you love math, you never get wrong with math. Absolutely never. So.
Thank you for that. Another audience member asks, What advice would you have for an international undergraduate pursuing STEM in the US given restrictions in SULI and REUs?
Yeah. So I will have to say that when I came from Costa Rica, it was a little easier in many ways. And I cannot comment on politicals right now, right, for a lot of reasons. But I would say that try to find internships where visas are not a constraint, or you don't need to be a green card holder or a US citizen. There are still a lot of opportunities. Many universities have opportunities through the summer, working with professors, etc. So this is a venue too that you can actually, you don't need, you are already in that university, you are already with their visas, permits, etc. And so explore that. And but do something. Don't get yourself just confined. Just saying, well, I am not a U.S. citizen, I cannot go Asuli, but you still can do research with your professors at the university. Some companies also might be able to because it's a three-month period. I'm not an expert in visas either, so don't get me that word. But typically, the universities will be your best bet to work with in the summer.
Great, thanks. Another audience member asks, I know for smaller universities, there are chances to talk to other majors and see what other people are working on. Would you say national labs have a similar environment where you can go talk to other research groups, or do you mostly focus on your own research group?
No, so there's a lot of ways, in like for our interns, right? I'm talking about our interest population where we have poster sessions, we have a lot of opportunities to get the interest together to talk, right? So that is a way for us to say, well, I'm a chemist, but I want to learn what a nuclear engineer does. So through those professional development opportunities is when you go. Even if it is not a poster session, it could be a talk by someone. Typically all the talks are posted. So I always encourage people to see something that is not in your field because you never know if you actually going to be falling in love with that field and then go to talk to the scientist who is leading that research. So really get out of your field or your comfort zone. Lots of people are very generous with their time. Many times I would just simply email and say, hey, I have this question. Can we go for lunch or can we have a meeting for 10 minutes? And people are typically very generous and everyone's love to talk about what they do. It's for a fact. And so when you ask someone, can you tell me what you do? They get excited and they will generously give you time of the day to talk about it.
Thank you. Another audience question, what types of careers are available for mathematics majors at Idaho National Laboratory?
Oh, a lot. So right now, obviously, computational modeling is huge. Genesis mission is huge. All of you who can do mathematical modeling, who can actually work with computational scientists or so, you are all welcome, right? Sometimes we are constrained by our majors, but we many times we know that in science it's not just one group of people doing, right? So it's always a group of minds together to solve a complex problem, right? And all of us bring different points of view and perspectives and experiences. And so the most effective teams have people from a lot of different fields. And so when you're looking for opportunities in to be interns or so, apply to areas that are, computational science, that are so many chemical engineering, reactor design, so many areas where your talent is very welcome.
Great. And our final question, with all of your experiences throughout your career, what advice would you give to your younger self who is trying to figure out maybe next steps? Maybe you're in the position that you're an undergraduate or a graduate student or early career STEM professional. What kind of advice could you give your younger self knowing what you know now?
So, it's interesting because someone asked me this question not long ago. I would say do not regret anything I did. I do not regret any the other way that my career was. However, I will network more and more and more. Have more mentors, a network, a larger network of people that I actually can go and ask questions, right? Um, Most people think that your supervisor, etc., is just one way to actually ask for advice. What we know now is that you need a lot of people to actually support you through your career, and also be more flexible in terms of learning, in terms of taking risks. I took a lot of risk when I was young, but not enough. Now that I have my sons, I told them, take the risk. This is the time in your life when it's time to make your mistakes. And not only mistakes, what I mean is take the risk. And the consequences are not as bad if you are mid-age when you now have more responsibilities. So I would say taking more risk and opening a larger network. That's what I would have done differently.
Fantastic. Well, on that note, Dr. Sandi, thank you so much for your presentation, and thanks to everyone for attending. At the conclusion of this webinar, a Zoom tab should open up for attendees to answer a quick 3-question survey, and we'd appreciate your input. And please be on the lookout for our next email advertising the seminar series in July. And on that note, again, Dr. Sandi, thank you so much for your presentation and for taking the time to share your wisdom and expertise with all of us.
Thank you, Natasha, and thank you everyone for coming. And again, Natasha, you can share my email, and I'm happy if people have questions, happy to answer them.
Fantastic. All right. Take
All
care,
right.
everyone.
Thank
Thank
you.
you.
Bye bye. Take care.